So now we want to add and subtract polynomials. But first, we have to talk about positive and negative polynomials. So we already know that a term can be negative. Negative 3x cubed. That's a term, and the term is negative. Terms can also be positive, plus 2x, and terms can also have no variable configuration, 3. So I've strung together 3 terms to make a polynomial. This polynomial doesn't have any sign. It's neither positive or negative at this stage of the game. This negative belongs to this term, this positive belongs to this term, and this negative belongs to this term. There's nothing that belongs to the whole thing. Once I group them into parentheses, then whatever number is in front tells me whether the polynomial is positive or negative. So if this were a negative polynomial, there would be a minus sign out front saying this whole number is negative. And if this were a positive polynomial, there'd be a plus sign out front, or nothing out front if it's in the beginning of a string of polynomials, and it would be a positive polynomial. So what happens if we have positive or negative polynomials? Well, let's look at the case where this is positive. If this is a positive polynomial, the question is, do I really need these parentheses to hold it together? Because it's a number, it's just one number. So do you need to hold a one number together? Well, you don't really need that, right? This positive just means that all of the signs inside are whatever the signs are. I could lose the parentheses and say this equals negative 3x cubed plus 2x minus 3 and go on about my day. Everything's great. But on the other hand, what if that very same polynomial were a negative? 3x cubed plus 2x minus 3, and I'm saying that this is a negative number. Well, we know just as with integers, so 2 is a number, and negative 2 is also a number, but negative 2 is the opposite, right? These are opposites. So if negative 2 is the opposite of 2, negative this polynomial is the opposite of this polynomial. But the polynomial has many parts. So in order to make this polynomial the opposite of this one's positive, this one's negative, so this is the opposite of this one. In order to make that happen, I have to change all the signs inside. So I want the opposite of all the parts. So the opposite of a polynomial is the opposite of all the parts. The opposite of negative 3, positive 3. The opposite of 2x, negative 2x. The opposite of 3, positive 3. So this is the negative polynomial for this polynomial. This is the negative number for this number. Kind of cool, huh? There's another way to look at this. Instead of thinking of take the opposite of all the parts, which is my favorite way to do it, you could also consider this negative as representing negative 1, right? Isn't a negative anything the same thing as multiply? Isn't this negative 2 the same thing as multiply the positive by negative 1? Or I probably should write that the opposite direction. Ha ha ha. That was a little joke. Negative 1 times positive 2. Negative 1 times positive 2 is the opposite of positive 2. I can think of it that way and then treat it like distribution. Negative 1 times negative 3x squared, positive 3x cubed. Excuse me. Negative 1 times negative 3x cubed, positive 3x cubed. Negative 1 times positive 2x, negative 2x. And then negative 1 times negative 3, positive 3. Okay, so basically what we've done now is we've looked at positive and negative polynomials, and this information is going to help us add and subtract polynomials. So let's start with an example. Let's take negative 2x squared plus 3x minus 5. Right? So this is one number, and we want to add this first number to 5x squared plus 7. So first let's look and see what we have. We have a trinomial, a second degree trinomial, plus a second degree binomial. Can you add and subtract binomials and trinomials? You certainly can. No problem here. So let's first get rid of the parentheses. So this falls kind of under the category of PEMDAS, right? Okay, so we're going to get rid of the parentheses. What would it take to get rid of the parentheses? Well, notice what we did here. If there was a plus sign out front, we just got rid of the parentheses. There's a plus sign here, get rid of the parentheses. Because it's a positive number. No problem there. Then there's a plus sign here, get rid of the parentheses. But this plus sign actually, this plus sign tells us to add these two numbers, but I have to remember, because I have to separate these two numbers from each other. Excuse me, two numbers, three parts. This plus sign separates these two numbers. But once I get rid of the parentheses, I need a way to separate these two parts. But remember, this term has a plus sign. We just don't tend to write the plus sign if we don't need it. So there's a plus there. So now I've dealt with the parentheses. The exponents, there are exponents in here, but there's nothing I can do to simplify the exponents. X squared is just x squared. No doing anything there. Multiplication, division, there's none of that. And now I'm going to add and subtract. Add and subtract polynomials. We'll talk about multiplication and division in a little while. But add and subtract polynomials. And that means I want to put all of my terms that have the same name together. And I'm going to cross out as I go. So starting with the highest degree, which is a 2, and I have 2 of them, I'm going to write these two terms next to each other. Minus 2x squared plus 5x squared. Okay, so I put my two x squared terms together, and then my 3x, and that's the only 3x, that's the only x term I have, and then my constant terms, minus 5 and plus 7. So notice it's really just a matter of putting my terms in order and letting the sign that lives with it just go along for the ride. And when I'm finished, I have what looks like a 5 part polynomial, but it's not 5 parts because these two terms can be combined, right? These two terms both have the same name. They're x squared terms. And so when you have the same name on your terms, you can combine them. So with polynomials, adding and subtracting, or adding at least, well, adding and subtracting is combine like terms. So when I add and subtract the terms to each other and from each other, I'm combining terms that are alike. Since these are alike, they're both x terms, I can just combine the coefficients. Negative 2 plus 5 is 3x squared, and I'm done with that. And now let's look at the next one. Well, I have one x term, so combining that is super easy because that's all there is. It's a 3x, and the sign on it is a plus. And now I want to combine my constant terms. Negative 5 plus 7 equals 2. And so the answer ends up being a second degree trinomial That's it. I don't know why I thought there was more to say. That's it. All right, let's do another example. I'm actually going to do the exact same numbers, but this time I'm going to subtract. So my first number, negative 2x squared plus 3x minus 5. And this time I'm going to subtract the second number, 5x squared plus 7. Okay, so the first thing I have to do is get rid of the parentheses. If it's a plus sign out front, It just means all the parts have the right sign on them already. Negative 2x squared plus 3x minus 5. So I just dropped the parentheses because I'm not worried about the sign change in the first number. But the second number is, this tells me, this part tells me that I want to take the opposite of this whole number. And in order to take the opposite of that number, I have to take the opposite of each of the parts. So 5x squared is positive here. The opposite of 5x squared is negative 5x squared. And then the opposite of 7 is negative 7. And so now I've gotten rid of all my parentheses. And I'm going to do exactly the same thing I did up here. I'm going to combine like terms. Again, I'm going to do it by crossing out as I go, so I keep neat track of what I'm doing. My highest degree is a squared term. So I have a negative 2x squared and a minus 5x squared. And that's all my x squared terms. The next smallest degree is a degree 1 term, and I only have one of them. And then I've got my constants, minus 5, minus 7. Okay, so now let's combine. These have the same name. They're x squared terms, and so I can combine those by combining the coefficients. Negative 2 minus 5, negative 7, x squared. The next degree, or the next name term, is an x term, and I only have one, and it's positive 3 plus 3x. And then the last name terms that I have are my constants. And the constants combine just like we've been doing forever. Negative 5 minus 7 is negative 12. And so again, in this case, I ended up with a 2-degree trinomial. But it's definitely not the same number. So I've subtracted 5x squared plus 7. And in the first case, I added 5x squared plus 7. Now, you might be wondering, what is all the algebra here? What's the part I have to show when I do my own work? Well, you have to write the original problem. Always. There's no exceptions there. I don't care how big the number is, you have to rewrite it next to whatever the problem number is. So you rewrite the original problem, and then you have to show that you got rid of your parentheses. You have to show that. The step you can leave out is this regrouping step. I don't recommend it when you're starting off because you're going to make or likely to make a bunch of mistakes, but this is an acceptable step to skip. You can combine all of your terms and write the final answer. So these 3 steps are required when you're combining or adding and subtracting polynomials. On this second example, this first problem, you have to write it, have to write the original problem. You have to rewrite all of the terms, taking into consideration whether they're positive or negative numbers, and then you have to write the final answer. Again, you don't have to regroup putting like terms together. It's a smart thing to do in the beginning, but you don't have to do it. But the proper algebra for adding and subtracting polynomials is to show these 3 steps.